All right, so let's have a look at some examples here. So here, we'll start with the proof of this, because proofs are usually the more difficult things here. So we have some information here. I'm going to go ahead and label what we have. So AB bisects CAD, and CAB is parallel to CB, is congruent to CBA. We want to show that CB and AD are parallel. So I don't know these are parallel here. I'm just going to mark them in black. I don't know if they are. But I will mark the things that I do know in a different color here. So AB bisects CAD here, right? It makes sense. So that means these two angles are congruent here, right? We can mention that. And then we also have CAB congruent to CBA here. All right. So notice that we can actually show that all three of these green angles are congruent here. And that's going to be important to us because that's going to tell us what we need to do. So now we seem to have a strategy here. These two angles are congruent. These two angles are congruent. So that means BAD here and CBA are congruent to each other. And those happen to be in the alternate interior angle configuration that we want here. So that we can use that to prove that the lines are parallel. So now that we have our plan, let's go ahead and write this one out, right? Now we know what this is going to look like here. So let's write this theorem out here. Let's write this proof out here, ladies and gentlemen. Okay, so we're going to go ahead and write this one out. So now we know what our general strategy is here, right? We're going to go ahead and introduce our givens here. So AB bisects angle CAD here. That's going to be a given piece of information to us, right? And then from there, we know that since AB bisects CAD here, we have the fact what an angle bisector does. It splits an angle into two congruent pieces. So CAB is congruent to DAB here. And that's our definition of angle bisector. So keep that in mind, ladies and gentlemen. Okay, CAB and DAB are congruent. Now I can introduce the other given. CAB is congruent to CBA here. That's also given to us. That's important. So now we can put this all together, right? It makes sense now what we can do. These two angles are each congruent to CAB, so I can now set them congruent to each other. So DAB is congruent to angle CBA here. And that's our transitive property, right? And then that is steps 2 and 3. So notice again, I'm still using the same construction I did from Boolean logic here. So you can see what statements each theorem is being applied to. And now we can finally put it all together. We can now put everything together here. Now we have our alternate interior angles. So that guarantees us that CB is parallel to AD here. And now we can say that if two lines are cut by a transversal so that the alternate interior angles are congruent, then the lines are parallel. And that's from step 4. So you note that, this sort of setup here is very similar to the proofs that we've been doing here. You can very easily convert this into a paragraph proof by simply writing it out, converting each statement, each pair of statements into a sentence here, right? One thing to note, again, remember, ladies and gentlemen, is that you want to make sure that you write your theorems out in full. You have to get in the habit of writing these out in full here. Make sure that you understand what's going on, especially since we have many theorems that have very similar constructions here. By writing your theorems out in full, we know, first off, you know what the theorems you're talking about, and two, you're writing, and we know which direction you're going here, right? Here, we're using the one that allows us to prove that two lines are parallel. That's important here, right? We can't use the converse here because the converse assumes that the lines are parallel, and we don't have that. We don't know the lines are parallel. We're trying to show that here, okay? So you'll see that, in the homework, there'll be more examples of these sorts of proofs here, and of course, there will also be numerical examples, which we will see in the live portion of our class here. But hopefully this should make a lot of sense to you, and if it doesn't, well, feel free to ask me questions about it later on.